Hello everybody, welcome to Honors Algebra 2, 7.6, Day 2. We're going to solve some exponential and logarithmic equations again, but we're going to be doing them where we're doing the opposite of what we did yesterday, or in the last video. So if you look, this is the new thing that we're doing. If you have a log base of something, of a value equal to the log base, the same thing of a different value, then these values have to be equivalent in some way or another. So that is what the new thing is that we're looking at. Now they have to have the same basis. So if you look at example 1, you can see that this is a log base 3 and this is a log base 3. There's only one term here and one term here, which means that these two things must be equivalent. So 5x minus 1 has to be equal to x plus 7. And then we solve this like we'd normally solve it. We bring an x over here, so this subtract an x, add a 1, 4x is equal to 8. Divide both sides by 4 and x is equal to 2. Now the thing that we have to do here is we have to always check and make sure that our solution doesn't make this value inside negative, because we can't take a log base 3 of something and get a negative number. And 2 works. It doesn't make this negative and it doesn't make this negative. Coming over here, notice they both have the log base 2, and there's one term on each side of the equation. So we just set them equal to each other. X plus 2 is equal to x squared. And now we would have to solve it. I'm going to bring everything over here. So this is going to be x squared minus x minus 2, and set it equal to 0 to solve it. So I use the commutative property and put the 0 on the other side. This does factor very nicely. Hopefully you know how to do this. We need an x and an x. We need a plus and a minus. Factors of 2, whose difference is 1. So we're going to put the 2 with the sign of the middle term. So that's going to be 2, and this is 1. You put the bigger one with the sign of the middle term. Solving for zeros, we get x equals negative 1, and we get x is equal to 2. And neither one of these will make them 0. So we're good. Those are our answers. Forgot to circle this guy over here. It's not circle, square. Not square, rectangle. Oh, you guys are having fun probably. This is natural log here. This is a natural log here. Since there's one term on each side, we just set them equal to each other. Subtract 2x from both sides, and I'm going to subtract 1 from both sides. 2x is equal to 4, x equals 2. Neither one of those make this 0 or this 0, so it works. Coming over here, same thing, log base 8, 1 minus x. They're going to be equal to each other. 11 minus 6x is equal to 1 minus x. I'm going to add 6x to both sides, and I'm going to have 5x over here and subtract 1 from both sides. 10 is equal to 5x, so x is equal to 2. Now I need to check this and see if this works. If I put a 2 here, I get 11 minus 12, it's negative 1. I can't have a log base 8 of negative 1. This would also be negative 1. You can't raise 8 to a power and get a negative answer. It doesn't work. So this is extraneous, and I need to mark it as such. Okay, that is that type of problem. Now I want you to take a look at these. These are slightly different because this one has a term 2 that's not log base 5. And if you look over here, this one has a 28. So what we're going to have to do is get the log by itself. I should have put that as a step first. If you get the thing by itself, then you exponentiate each side, raise each side to that base, and then solve as usual and check your answer because we can't have a negative in there. Okay, so what we're going to have to do with this one, this is all by itself. There's not a 2 in front of it. We're not adding anything to it. So what we're going to do is we're going to take both sides and exponentiate it with a 5 as the base. So this becomes 5 squared. These two undo each other. That's the whole reason why we did that. So now we have 3x plus 1 is equal to 25. Solve it just like we normally would. 3x equals 24 and x equals 8. Check and see if it makes that negative. It does not. That's our answer. Over here, now this one has a 4 in front of it. So since it has a 4 in front of it, we have to divide it out. So log base 3 of x is equal to 7. Now we have to undo the log of 3. We have to exponentiate that. So we're going to raise 3 to the log base 3 of x is equal to 3 raised to the 7th power. All right. Now these undo each other. They undo each other, leaving us with x is equal to 3 to the 7th power. And I did this ahead of time because I don't know what 3 to the 7th power is. It's a big number. 2,187. And that does not make that negative. So we're good with that. Okay. Moving on. Oops, gotta fix things. Gotta fix up my classroom. Boy, do I miss my slow Promethean board right now, guys. Okay. Now this one has 3 terms. And what we're going to need to do, remember what the base of log is. It's 10. So we're going to take and exponentiate every single one of these terms. We're going to say 10 to the log of 5x plus 10 to the log of x minus 1 equals 10 squared. These logs undo each other, leaving us with 5x plus x minus 1 equals 100. 6x, we're going to add 1 to both sides, equals 101. And then we would divide both sides by 6. Let's just call this x is equal to 101 divided by 6. You can do that out if you want to. I didn't. And does that make it negative? No, it does not make either one of these negative, so it works. Now we're looking at this one. We have that 1/2 out in front. We want to get rid of that, so we're going to multiply both sides by 2. We will have the log base 6 of 16x is equal to 6. Now we need to exponentiate it. The base is 6. We're raising everything up. 6 to the 6th. Again, these will undo each other, leaving us with 16x is equal to 6 to the 6th. I'm just going to put 6 to the 6th. Divide both sides by 16, and this does come out nice and even. X is equal to 2,916. That's an exact value, as was this before we didn't make it a decimal. Okay, number 9. The first thing we're going to do, see, we have 3 terms. 1, 2, 3. We're going to put the 7 over here. 2 natural log of the opposite of x is equal to 7. Divide both sides by 2. The natural log of the opposite of x is equal to 7/2. I want you to think now, what is the base of a natural log? Because we have to exponentiate this. So what is the base of a natural log? It's e. So we're going to take e to the natural log of the opposite of x is equal to e to the 7/2. We get the opposite of x is equal to e to the 7/2, or x is equal to the opposite of e to the 7/2, which is approximately, did I do that? Yes, negative 33.115. Took it out 3 decimal places. And if you put that back in here, the opposite of negative 33.115 is a positive value, so this will indeed work. And if you go to plug that back in and check this out, and you did this side of the equation, you would get a number very, very close to 14. You won't get it to be exactly 14 when you check this because we've rounded. We've rounded, so the rounding will not get us exactly at 14. That's why we use the approximate symbol right here when we say it's approximately equal to. Coming up here, I need to move this over so you can see the other side of it. Move it slightly over. There we go. I'm using a ring stand to hold my phone, so that's what I keep moving. I have to undo each of these. And undoing a natural log, remember the base, we exponentiate it, is e. E to the natural log of x plus everything gets raised up. X minus 2. Everything gets raised up. These undo each other, leaving us with x plus x minus 2 equals e. 2x minus 2 equals e. Add 2 to both sides. 2x equals e plus 2. Divide both sides by 2. X is equal to e plus 2 divided by 2. Now, if you're using a calculator and it's asking you to, it gives you a prompt that says e, and then you have this, just put a 1 there, because that's just e to the first power. And then make sure you end it before you add 2 and divide by 2. Order of operations there, and you get about approximately 2.359. Approximately. Now, if I look back up here and I see if that'll work, that's positive, that works. And 2.359 minus 2 is also a positive value, so we don't have to worry about that being extraneous. Okay, oops. Can you, oh yeah, I went off the grid there. Sorry guys. 2.359. Give you a few seconds to check that out. All right. Moving along, we have example number 11. We have negative 5 plus 2 natural log 3x equals 5. So the very first thing we're going to do with this one is we're going to add 5 to both sides. So we have 2 natural log 3x is equal to 10. Be careful, a lot of people will look at that and think that's going to be 0, but no, we're adding 5 to both sides. So that's a common mistake someone might make. Divide both sides by 2. The natural log of 3x is equal to 5. And now we have to undo the natural log. The base is e, exponentiate that up. We end up with 3x here is equal to e to the 5th. Divide both sides by 3. X is equal to e to the 5th divided by 3. Now that's an exact value right there. If we do it out, we're going to put approximation 49.471. And that's not a problem because that still would be positive. Okay, and the last example problem. We have 2 terms. We're going to divide both sides by 6.5. So log base 5 of 3x is equal to 20 divided by 6.5, which is about 3.077. Now we have to undo the log base 5, exponentiate that. So we have 5 to the log base 5 of 3x is equal to 5 to the 3.077. So 3x is equal to 5 to the 3.077. Divide both sides by 3. We've got some rounding errors that are going to occur, but we're going to do the best we can with what we've got to work with, about 47.163. And we do not have to worry that that is going to be extraneous because that will be positive right there. Hopefully this is understandable. And if you have any questions, please feel free to email me. You can always stop the video and go back and listen to a problem if I've gone too fast. That's a nice thing about this. You can rewind. I hope everybody is doing well. Again, I miss you guys like crazy. Take care.